All right, we'll just go through the whole thing together. Yeah, you could just do it as we go. How's that? That's what most of you guys have been doing anyway, right?
Yeah.
AJ, I figured that.
Yeah, AJ, I figured that. AJ Miller.
All right, we got a couple more from chapter 6 to finish up. Number 21 is just a calculator problem. The change of base formula is what we're using. But here's what we put in the calculator. Log of 10 divided by log of 4. The base stays in the basement. Okay, so let's get my calculator out here. And we'll get some decimal answer, which is fine. All right, so just remember to close up your log, because when you hit the log button, it gives you that left parenthesis. So close it off, and the bigger number stays up top, and then the base stays in the basement or the bottom. All right, so 1.661. I think we went, when we did these, I think we went to thousands. I don't remember. I think that's probably a multiple choice one. I don't know if it's just a hundredths, but you'll be able to pick out the correct one for that one. All right, so just putting it in your calculator, one like that. Number 22, we're expanding. So we've, on number 15 and on number 19, we condensed it. All right, addition we changed to multiplication, and the subtraction one we changed to division or a fraction. Number 22, we have multiplication, so when we expand it, we turn that into addition. All right, so we got this 3 times, we don't have the times symbol, but that's what's going on there, right? The 3 in front means 3 times x to the 4th, right? So we turn that into 2 logs when we expand it. So we go keep the same base, and that multiplication becomes addition. Would this be expanded all the way? Is that finished? No. What else do I have to do? You got to move that 4 in front. Yeah, they don't want any exponents when it's expanded. So the last step would be log base 6 of 3, and then take the 4, that's the exponent, in front, and that's 4 times the log base 6 of x. So that's what we're looking for when you expand it. If that was, 3 over x to the 4th, as a fraction, then we'd make it subtraction. So remember, multiplication, we turn into addition when we expand, and then division, we would turn into subtraction when we expand, okay? Any questions about chapter 6 stuff? Any more questions? I think that's it, right? Yeah. All right, then we're moving on to chapter 7, which starts with number 23 here. And we're supposed to graph a function. And it's a rational function. It's a fraction. When we do this, we did it in our calculator, but you want to make sure that you put parentheses around your numerator and your denominator. Okay? So when you put that in your calculator, put those in parentheses so it'll look the way it's supposed to look. We call these graphs hyperbolas. They had two branches to them. Okay, but what we did is we figured out the vertical and horizontal asymptotes, and we drew those in. and then we looked at the graph. Okay, so the vertical asymptote is what makes the denominator equal to 0. So we got to figure that out. Okay, since that 3 is in front of the x, I would suggest you write it out, the actual equation, and do it. Okay, so you're going to add 1 to both sides, and then divide by 3. So that's our vertical asymptote. So if I put some marks on here. Okay, 1/3 is just past 0. That's vertical asymptote, so that would be a vertical dashed line through the 1/3 on the x. Okay? The horizontal asymptote is this fraction, those two coefficients. Okay, when it's written this way. All right, so my horizontal asymptote is y equals 4/3. Okay, that's 1 1/3, so that's a little above the 1, and that's the horizontal asymptote. That's a horizontal dashed line, right? So there's our two asymptotes. Okay, and then when you graph it, go to your y equals, and remember, put parentheses around the numerator and denominator, 4x plus 2 divided by, and then parentheses, 3x minus 1, and then hit graph. And you see the two branches, okay? So this one is here, and this one is up here. The asymptotes are the pieces of the graph, those two lines are where the graph won't touch. Our two branches don't touch those lines. That's what an asymptote is. You're also supposed to find domain and range, right? But once you know the vertical asymptote, you know the domain. Okay? The domain is x and 1/3, but instead of equals, what do we put?
Yeah.
Does not equal. Okay? And the range is the same as the horizontal, and the same thing. It's not y equals 4/3, it's y does not equal 4/3. That's how we wrote it. Actually, what we're saying is the domain is all real numbers except 1/3, and the range is all real numbers except 4/3. But we just wrote it like that. Okay? So I think that's one of our free response ones, where you actually have to graph it. It's not a multiple choice one. Okay? Remember, the first 10 are free response, like we're doing the whole practice, and the last 20 are multiple choice. All right, this wasn't that long ago. Any questions? Calculator helps us. Okay. So whatever makes the denominator 0 is our vertical asymptote, and then the two coefficients, top and bottom, make up our horizontal asymptote. Okay, number 24 was subtracting two fractions. To add or subtract fractions, you need a common denominator. So the first thing we would do with these is try to factor denominators if possible. Is it possible to factor any of these denominators? No. Right? They're as simple as we can make them, right? So, since they're already basically factored, what was the common denominator? Whatever showed up, what did I tell you to do? Write it down, right? So, an x minus 2 shows up, and an x shows up, right? X minus 2 showed up again. We didn't have to write it down more than once, right? So what we do is we multiply all three fractions by that common denominator. And when we do that step, that eliminates our fractions. Okay, that's the goal, to eliminate those fractions as soon as possible, right? So when I multiply this first fraction, 5 over x minus 2, times that common denominator, what happens to the x minus 2's? They're gone. So it's just 5 times x, which is 5x. Okay? When I multiply this 2 over x times the x minus 2 times x, what goes away? The x's. So I multiply negative 2 times the x minus 2. Again, one more fraction. That's why we're doing this. When I multiply the third fraction, the x plus 3 over x minus 2 times my common denominator, what cancels? The x minus 2's, right? So then it's just x times x plus 3. So that's what our equation looks like now. So now I just simplify and combine like terms and see what happens. Okay, so I'm going to distribute by negative 2. And I'm going to distribute my x. Okay? So what is 5x minus 2x?
3x.
3x. So this one's kind of nice because what happens to those 3 x's? They're going to end up canceling each other. You guys see that?
Yeah.
Because I'm going to subtract one of them over to the other one and they end up canceling each other. So instead of setting it equal to 0, since those end up canceling, I can just do that problem. What can I do to both sides now? Square root, yeah. So let's just square root both sides. And remember, when we do a problem like this, and take the square root of both sides, since it's an even root, what symbol is in front of my answer? Yeah, plus or minus, okay? So don't forget about that, plus or minus. Now, we should check. If I put a positive 2 right there, what number do I get?
0.
0. So is positive 2 a good answer? No.
No.
So positive 2 is not a good answer. The only answer then is what? Negative 2 is okay, because I get a negative 4 when I plug it in there. I still have negative 2 there, so my only answer is negative 2, even though we got 2 answers. Okay? So, common denominators to add or subtract are rational equations, are fractions. Questions? Okay. 25 is a multiplication problem of 2. I think it's multiplication, isn't it? Or the division. Oh, it's, 23. Why am I, did I mess up?
Yeah, the numbers are screwed up.
It goes 23, 24, 23, 24.
And then
Oh, it does. How did that happen?
So we're on 25. So we'd be on the second 23.
Yeah. Man, I messed that up.
That's alright.
I gave you more problems than 30 then, didn't I?
Maybe 2.
But on the exam, there's only 30. Okay?
Which ones are gone?
I don't know.
Well, let's just limit
Just-
these next two.
Let's just,
Yeah.
let's see. I think there is one like this 23. So
Good work.
second 23,
Good work.
Can we get rid of that one?
simplify one.
No, it's on the.
I don't remember which ones are and aren't on there now. All right, sorry about that.
Alright,
I didn't even realize that happened. All right, so 23
again.
again, right? Number 2, 23 there. All right, just so we go over, because I don't remember which ones I eliminated then. So simplifying a fraction is we have to factor what we can factor first. Okay? So the factors of negative 18 that add up to negative 7 are a negative 9 and a positive 2. And then x squared minus 4 is a difference of squares, square root of x squared, square root of 4, plus and minus.
Oh. Why you do that? Why you do that, bro?
Thanks. Welcome. Gotcha. You didn't know you were leaving.
What is that? It wasn't good.
Okay, so do we see any common factors top and bottom? Yeah, the x plus 2's. So those cancel out. So our answer would be x minus 9 over x minus 2. All right. So 24, number 2. Was another multiplication problem. Well, we haven't done one yet, I guess. But we have to factor what we can factor first. Oops, that's minus. Okay, so GCF in the top left. Yeah, since it's negative, I'm going to pull that out. I don't like my x squared to be negative, so I'll pull the negative 3x out. And then what's negative 3x squared divided by negative 3x? X. What's 12x divided by negative 3x? Negative 4. Factors of negative 8 that add up to negative 2 are negative 4 and a positive 2, right? Difference of squares, x plus 2, x minus 2. And then I got a 3x. So, canceling x plus 2's, x minus 4's, 3x. Everything's gone in the bottom. So I don't have any denominator left. Put 1 if you want. What's my answer?
Negative x.
Yeah, don't forget that negative is still there, right?
Yeah. Ooh, that checked it not.
So there's our answer. Okay?
Yeah, we're the answer. Be false.
You don't have to put it over when I'm done. All right, number 25. I turned it into multiplication. Multiplying by what? Division is multiplying by the reciprocal. So here's how I would write it when I would write it down. So this would be 1 over x squared plus 2x minus 3, right? So that's how I would write it down when I would go to do this problem. Because it was division, but we're changing it to multiplying by the reciprocal, okay? So now I factor. It's going to be x minus 1 and x minus 2 for the top. Negative 1 times negative 2 is positive 2, and negative 1 plus negative 2 is negative 3. It's going to be x plus 4 and x minus 2 to get 4 times negative 2 for the negative 8, and 4 plus negative 2 to get the positive 2. And then x plus 3 and x minus 1. 3 times negative 1 is negative 3, and 3 plus negative 1 is positive 2. All right, so now I can cancel some common factors. Let's see here. Minus 1s and the minus 2s, right? So my answer is 1 over x plus 4 and x plus 3. So that's just, those types of problems is just factoring and canceling, right? 23, 24, the second ones, and 25, okay? 26 is like 24, where you have to add. So we gotta get a common denominator. So I imagine you would have one like 24, one like 26. I'd probably drop one of those. Because they're the same type of problem. Finding the common denominator first. So 26, we can factor this first denominator, x minus 7 and x plus 3. Okay? So what's going to be my common denominator? And whatever shows up,
That's what you
you got to put it down, right? So x minus 7 and x plus 3 is going to be my common denominator. So what I'm going to do here is just make this the same. Okay? So now I've made both denominators the same. So I had to multiply the second denominator by x plus 3, so I multiplied the second numerator by x plus 3. Remember, you got whatever you do at the bottom, you got to do at the top. So the first, or this becomes 2x plus 6, and now I can combine like terms.
Whatever shows up, gotta put it down.
That's right. Don't forget that.
Not with dogs.
So, combining like terms for the addition, 0 plus 2x is 2x, and 7 plus 6 is 13. So there's our answer. We can't factor the numerator, we can't simplify it. Okay?
Wait, hold on. Let me take this in first. 13, I'm doing 7.
All right, the last one from chapter 7. I don't know why I had extras, but you won't have quite that many from chapter 7. But you have one like this. This is really easy. You're supposed to tell me the vertical asymptote. So what is it? Yep, that easy. Just whatever makes the bottom 0, right? Whatever value of x makes the bottom 0. So that's an easy one. Similar to 23, the first 23. Okay, vertical asymptote. Just in case, I don't think I asked you this, but what would be the horizontal looking at that one? Say that again, bro. Yeah, the -1 is the horizontal one. When that's just a single number, like this is, it's whatever's out there. But I don't think I asked you that. I think all I asked for is the vertical asymptote like that. Okay, last chapter we went over was chapter 10.
It's the trigonometry one. It's the trig one.
Is the trig chapter? I'm not sure.
So this is a 30, 60, 90. So you had to find x and y. So what do you do to get the x? No.
Just joking. You were serious. I was serious. So it'd be opposite hypotenuse. So it'd be Hoa.
It's a 30, 60, 90. You're supposed to know this.
Louder.
Louder, Connor.
Huh?
Louder.
Divided by 2.
Divide by 2, right? You get over here in the short leg, divide by 2.
We just did this.
Yeah, we just did this.
Okay, well, I didn't do good.
And how do we get from here to here? Multiply by radical 3. That's all you gotta do. Okay? If you need to draw that special triangle on your note card, go ahead.
True, I should do that. Yeah. I think we should do that.
So this was x, this was 2x, and this was x radical 3, right? The 45, maybe on the exam it's the 45 instead.
It's the 45. 45.
These were both the same, so we made those x. And what was this? Radical 2, good, Brock. So those are the 2 pictures for those special right triangles that we had on that last quiz, which was what, Tuesday, right?
Yeah.
Just 3 days ago. Yo, you remember that, right? Okay, now 29, there is one very similar to this. Okay, well, just like it, just different numbers. But we didn't have one like this on our quiz, so you guys need to pay attention to this one. So you got a 30-foot telephone pole. That's looks like that, right? Hopefully the telephone pole, not all of them, but most of them straight up and down, right?
30-foot telephone pole.
So it makes a right angle with the ground, right? And then shadow. Where's the shadow going to be?
It's going to be casting the hypotenuse. It's on the ground.
Yeah, the shadows are on the ground,
Yeah,
right?
it would cast it.
Right. The sun. Let's say the sun's up here, right? It's shining. It goes along this, like you're saying, Caleb. But you see the shadow on the ground, right?
You know what I'm
So the 24-foot shadow is the ground. Okay? We are looking for that angle. That's what I'm asking for. To the nearest degree, what is the angle of elevation to the sun from the end of the shadow? So here's the end of the shadow up to the sun. What's this angle? Okay? So we didn't do that on our word problems. Our word problems was you were given that angle and you had to find the side we were asking for, right? Okay. So,
is this the inverse?
yes, this is inverse. All right, so we're looking for this angle. Which side is that? Opposite. What side is that? So we're going to use what again? Tangent, right? TOA. So tangent, we've been using theta. You can use whatever angle or letter or whatever you want, symbol. Equals opposite 30 over adjacent 24. Okay? So to solve this, you have to do this in your calculator. Inverse tangent, which is that one. And put that fraction in. Now, what mode you got to make sure you're in? Degree mode. Okay? Caleb, quit breaking stuff. What'd you say? No, you hit second tangent. So you're going to hit second tangent. And then it'll show that in your calculator, tangent with that -1 symbol. Okay? So I'm checking my mode, make sure it's in degree. It's not. Look. Somehow it got put in radian, so I'm going to move over, hit enter for degree, and then I'm going to go second tangent, and then put that fraction in, close it up, and 51, usually to the tenths, 51.3 degrees. Okay? So we did similar stuff, but we didn't actually have to find an angle on our quiz. All right, so I wanted to make sure we went over that. So second tangent for that one.
It's Lego back.
Last one,
I know. Yeah, I know.
is a picture of a right triangle. And theta's here, and it said A was 3, and B was 4, and C was 5 for the picture. And you had to find sine, cosine, and tangent. Basically just like number 1 on your quiz the other day, right? So Katoa, right? So is opposite over hypotenuse. Ka is adjacent over hypotenuse. And Toa, opposite 4 over adjacent 3. So that stuff should still be pretty fresh in your minds.
Yeah.
Okay? Yeah. So, for participating this week on exam review, you should all get a 5. Maybe Nolan doesn't get it, or Caleb Collins, because they weren't doing anything. They were just sitting there today. You just sat there, didn't you?
I was watching
Everything on No, that's the only time I didn't put it. The only time I didn't put top of that. Oh, that's the only one I never wrote.
Extra numbers.
Because you just put 2 in for X, and then you subtract that.
So where's my
I don't.
screencastify stuff?
So it's 9 times this, and now you're trying to do 2 plus 2. Oh, okay.